All right, so this is AB Calculus, AB Self-Check 6.1. This was taken from the 2006 question number 5. This was version A, and I'll talk about that a little bit more in the next self-check. So if you actually Google FRQ 2006 number 5, you will find this question online. It's free. You can see it. You can see the solution guide that I'll be showing you. So the way that you do this one, you're plugging in each of the x and y coordinates. So if I, for example, plug in this one, I'm going to plug 1 and 1. So 1 plus 1 is 2 over 1. I should have a slope of 2. And I'm going to do these all kind of quick. So that's going to be 2. I'm going to have a slope of 1. I'm going to have a slope of 0 and 0 for that one because I have a negative 1 for the y coordinate. I have a slope of a half. I have a slope of negative a half. And these are all kind of flipped. So this was positive 1. This is negative 1. And this is going to be negative 2. The way that you score yourself is, this one is kind of unclear, but you can kind of see on the scoring guide, they say you get 2 points if the sign of the slope of each point and relative steepness of the slope lines and rows and columns. It's very unclear. The next self-check that we do is going to be a little bit clearer. The way I'm going to make this, I'm going to say if you got these correct, give yourself +1. If you got all of these correct, give yourself another +1. So you can get up to 2 points on part A. So over here on the left-hand side of A, give yourself something out of 2. Over here on the left-hand side. How many points out of 2 did you get? All right. And then we're on to part B, which is that hard question. You need to do your 4 steps because you see particular solution. Those are the key words that tells you, hey, we need to do separate, then integrate, then evaluate. Yes.
For them, you're supposed to use the same equation on top, right?
Yes, yeah, you're always supposed to use this equation. And yeah, it is a good question. The way that free response questions work is A is related to B, which is related to C and D. They can go all the way up to part D in some cases. So yes, I'm going to rewrite this equation. dy dx is now equal to 1 plus y over x. So that was the original differential equation. I have to have a fraction equal to a fraction. Done. Now I do left equal to the right. I should silence that. Cross multiply dyx, so x dy is equal to, and then cross multiply the other way. I still have that 1 plus y in parentheses times dx. Okay. So that's cross multiplying. I still need to do my separation. So I'm going to move my x to the left by dividing both sides by x, dividing both sides by x, and I'm also going to divide both sides by 1 plus y, divide by 1 plus y. And when I do that, my new equation becomes 1 over 1 plus y dy is equal to 1 over x dx. All right, so how do you score just this first step? So if you separated the variables, you just get 1 point. So if you have this exact equation, or maybe if you use negative powers already, give yourself +1. So at this step, I'm going to give myself +1. I should be circling those so they pop out. And then we're on to the next step. If you didn't do this step correctly, you can't get any points, unfortunately. I think that's what it says too.
So if you don't get the first step correctly, then
it's 0, yep.
All right.
And that's just reading this note right here. 0 out of 6 if no separation of variables.
Well, we can still get points on the first part, right?
Yes, you can still get points on part A. This is all part B now. And then moving on, we are going to do step 2, which is to integrate. So I'm going to slap on some integrals, and I don't want any fractions now. I want negative power. So this is going to be 1 plus y, all to the power of -1, yep, dy. And this is going to be equal to x to the -1 dx. Okay, no points gained yet. Now I actually have to take the antiderivative, and I know, hey, if I have a -1, I can't divide by 0, because I would normally add 1, then divide down. I can't divide by 0, so I need natural logs. So the answer here is natural log of absolute value of 1 plus y. And on the right side, it's natural log of absolute value of x. And don't forget your C. There are a lot of points happening here.
So you get 2 points for that?
So it says just for taking the antiderivatives, you get 2 points. So 1 for each side. 1 for the right side, 1 for the left side. So if you got natural log of absolute value of 1 plus y, give yourself +1. If you got natural log of absolute value of x, not even the cake, just not even the c, give yourself +1. Just the natural log of absolute value of x. It has to be the absolute value of x, by the way.
Cake is just like an apple?
And then the cake by itself is another point. Constant of integration. So if you wrote plus c, give yourself another point. All right, and then we're on to the next step. So we just did integrate. We're now on to evaluate. Evaluate means just plug in, right? This is my x. this is my y. My x is -1, so I come down here and say this is going to be natural log of -1 plus c, and that's all equal to plug in 1, so natural log of 2. If you did that step, or something similar like 1 plus 1, and you simplified, you do have to simplify my class to 2. A big step, right? 1 plus 1 is 2. Give yourself 1 point.
What if I simplified it first and got y by itself first? Equals -1 plus or minus.
And then you did evaluate later?
Plus, yeah.
Okay, I'll run through that just to show you how the points would work. But if you use the initial condition, that's where I'm doing that point. I'm going to check Claire's step right now, solving for y, which you don't need to do. Like, we're already up to check how many points we're at. Without even doing any isolation, not doing any hard math, we're at 1, 2, 3, 4, 5, 6, 7. If you did everything correct, you're at 7 out of 9 points. All right, and then let's talk about Claire's step, because she requested it.
Okay, so if I did it first, and then I plugged in the numbers later, even if you got it wrong, it's okay. So can I put the...
Please evaluate before you isolate, yes.
Oops.
You know for next time, right?
Does it still count as the point?
Yes, if you got it correct. I'm going to go through to see if you got it correct. So if I have the equation, I'm just going to copy paste here because I'm a lazy math teacher. I'm grabbing too much stuff. Okay, fine. I'm going to write it again. This is going to be natural log of absolute value of 1 plus y. Absolute value is equal to natural log of absolute value of x plus c. If you exponentiate both sides, then I get e to the power of this is equal to e to the power of this, and that cancels out, and I'm now left with, let's switch colors to yellow again. Absolute value of 1 plus y is equal to e to the power of natural log of absolute value of x, and that's going to be times e to the power of c. I can kind of, well, you might not have done that. You can still leave it to this giant power. I'm kind of skipping a step there. And then after I take that absolute value away, it's now going to be plus or minus on that side, e to the power of natural log of absolute value of x.
Doesn't that cancel out? So just...
Oh, yes. I should change that now. Yes, thank you. I was thinking about doing that in the next step, and you're right. I should just do it now. Those two do cancel out, and I'm just left with absolute value of x, and then times e to the power of c, and that's now 1 plus y. And then again, I can subtract 1 from both sides. Lots and lots of math happening here. If I subtract 1 on both sides, I'll just write it. Then I get y by itself, which is the isolate, and then that's going to be absolute value of x times e to the power of c minus 1. Again, that minus 1 there. So if you got all the way to that step, then you can give yourself plus 1.
I accidentally did plus instead of multiply. So
Okay.
my plug-in doesn't count either?
Your
Like,
your plug-in counts if you plugged in right here. It's just your isolate. It's a good question. It's a question for John. I'm pretty sure, I'm like 75% sure you'll get your point. Because you still used your initial condition.
So I should...
Give yourself a point, yep. But solving for why you don't get that point. And then I could talk about the domain, but again, it's I think it's pointless doing that. No one's gonna really. I feel bad for saying that, but like we're gamifying this. All right, that's it. Done. Give yourself points out of 9 at the very top. Hopefully you hit 3, and that's the goal, right? Yes. Question, Gio.
I had 2, but I think I can do better.
That's so close though. Like you're almost there. That's you're close.
So, oh wait. For the next part, like the checkpoint 6.2,
Yeah.
part number B, are we using the equation they've given us, or are we using this equation from number A?
Let me go open that up. So you're already looking at, oh wait, I already have it up here. I can scroll down. You're talking about 6.2, this equation right here?
Yeah, are we using that one or that one below B?
No, so this is just describing all points where this happens. Where this is asking, where is the slope -1, essentially. So for C, you're using this equation.
Oh, okay. Alright.
Can I see the rubric again?
Yes, so the rubric, this is posted on the website as well.
Find the domain.
I will talk to you privately.
You never told us. How does that?
Again, I can't talk about every single thing because we're going to run out of time. But I will. It's a good question. I want to answer it. I just can't do it. We're going to work on self-check now. All right, so self-check 6.2. I'll have 4.5 minutes to do this. Let's see how far we can get. So when I do the slope field, I should get 0 for all of these slopes. I should get a half here. I should get 1 here, -1. That should get 1. I should get 2, -2, -1, and -0.5. The way that you score yourself in terms of the solution guide, let's scroll up. Oh, that's the wrong one. Let's get rid of that so I don't get confused. don't save. All right. This one, the zero slopes, you get a point. So all of these zero slopes on the left-hand side, if you did every single one of those and they're zero, give yourself a point. If you come over here, the non-zero slopes, give yourself a point. So everything that's on the right-hand side, all 8 of those, give yourself a point. And then finally, this one was kind of hard because we have never talked about it. Sketching the solution of the curve that passes through the point 0, -1. We've never seen that before, but let's talk about it as quick as we can. So 0, 1 is, or 0, -1 is this point right here. So if I kind of had to follow this river of a slope field, I'd say, okay, well, I'm going to follow kind of the direction that this is pointing towards. So follow the direction, and kind of, it just makes a straight line, and kind of the backwards too. I don't know what happens here, so I'm just going to end here. And you can probably tell that it's just going to go straight on forever that way. So if you have some sort of line that ends at -1 that goes in this slope of -1 just perfectly down here, give yourself a point. And that's hard to do because we've never talked about it. But there it is. It can't have any curve, unfortunately. It has to be a straight line. Yeah, and we can practice more. I can print out like a crazy slope curve and put a bunch of points and see if you can kind of follow the slopes. Talking about point B, or part B. Describe all points where I have a slope of -1. So essentially the easiest way to do this is treat this as an equation, right? Well, let's multiply both sides by dx. If I do that, I get dy is equal to -1 dx. I just multiply both sides by dx. And then I can integrate. So if I do that, I get the integral of dy is equal to the integral of -x, or sorry, I was already taking the integral, -1 dx. And now actually taking the integral, I get y is equal to -x plus some c. In this case, it's going to be -x, and then since how can we figure out that c? I'm blanking on this. For which dy dx, it's all the points that lie on this. Oh, it's all the points that lie on this line. So check it out. That has a slope of -1. It's saying where do you have a slope of -1? Everything that is on this line has a slope of -1. So the y-intercept, this c, is -1. So the full equation should be y is equal to -x minus 1. So you can either just describe the line that has all these slopes of -1, or you can just kind of find the y-intercept that has a slope of -1 also.
So if we got the answer, but we didn't do like the integrate part, we just looked at the graph. How does that work?
So yeah.
So say again?
So like I just looked at the graph and I saw the like slope of the line through -1 and the y-intercept, and then I put them in the equation. But I got the same answer. So
Y equals -x minus 1?
yeah.
You get the point. Yeah, the thing that you have to have is you have to have y equals -x minus 1. If you have that, give yourself +1. If you described it in words, I'll have to come check by myself. But usually you describe these with an equation. And then for part C, I have exactly 40 seconds left, so I'm going to go ahead and pause right here. And I'll just leave the solution guide so you can kind of check the work that you have. All right, and we're back. So it's great that we grade ourselves, but make sure that we know how to do part number C, and that is the beginning of 4th period. So on this one, I'm going to rewrite this original equation. So x plus 1 over y, x plus 1 over y, and that is equal to dy dx. All right, so first you need to separate. I'm not going to write out those rules and you shouldn't necessarily need to either because that kind of wastes time. Cross multiply after setting a fraction equal to a fraction, which it is, so it's going to be y dy, and that's going to be set equal to cross multiplying the other direction, which is the quantity of x plus 1, all in parentheses, times, ooh, that was a bad parenthesis, times dx. That's separated. That's just +1 right there. And again, you can check the scoring guide. Separating the variables is 1 point. So +1. Next, I need to integrate, so slap on those integrals. Integral of y dy is equal to the integral of x plus 1, the quantity of that, dx. No points yet. I need to actually take the antiderivative. When I do that, antiderivative of y, it was y to the power of 1, so it goes y to the power of 2, and then divide down 2. Perfect. On the right side, it was, I'm kind of taking the antiderivative, I'm distributing that into both of these terms. That's the way that I always think of it. So antiderivative of x, well, it was x to the power of 1, so it goes up to x to the power of 2, and then divide down. Antiderivative of 1 is just x, so plus x. So if you took those antiderivatives correct on both sides, you have to get both of them to get this 1 point. That's +1 if you got both those antiderivatives. And again, there it is in the scoring guide. You have to do the antiderivatives. And then don't forget your cake. Don't forget your plus C. If you just did the plus C, that's just a whole another 1 point. All right, so next we need to evaluate. So evaluate, our initial condition is our x is 0, our y is -2. So our x right here is 0 squared over 2 plus 0 plus c, and that has to be equal to -2 quantity squared over 2 on the left. You do, in my class, need to simplify. My class is a little bit harder than the AP test, right? You don't get your point yet. You need to simplify. This is now 4 over 2, which is just, I'm going to write that as 2 on the left-hand side. And that's going to be c on the right-hand side, which is part of step 4, which is really nice. So if you got 2 is equal to c, then you can give yourself a point in my class. Well, normally on the AP test, you just leave it like this and don't touch it. Because if you make a math mistake on the actual AP test, and you like try to boil it down, you say, oh, it's like 1 plus c or something like that. Even though you plugged it incorrectly here, because you made a mistake here, they'll actually take that point away. They're like, no, you didn't use your initial condition, correct? So that's why I highly recommend on the AP test to just plug it in and don't touch it. Just leave it like this. But in my class, you do need to simplify. It is a little bit harder, as I've said. Okay, so now I am going to do that last step, which you don't need to do. So let me make this very clear. I kind of added back into the other notes over here that you do not need to find C. It's not required. It's not required to do this. So I'm going to make it very clear now over here. This is not required. So the following steps, not required. Let's go ahead and isolate. So I'm going to come back here to this original equation, and I'm going to say y squared all over 2, that's equal to x squared over 2 plus x plus, not c anymore, it's 2. We know what our c is. And I did make some changes up here too. I'm like, oh wait, we can find c all the way down here, and then I found it. Natural log of 1 is 0. And then I plug that in, and I kind of changed some steps. Like that step is now getting rid of the e natural log, so it's 2. And I'll come back and talk about the domain if I remember. So this one, isolate the y. Multiply every single term by 2, and if I do that, I get y squared is equal to x squared plus 2x plus 4. Then square root both sides, so I now get, change the color here, square root both sides, chunk and chunk. I get y is equal to plus or minus square root of x squared plus 2x plus 4. That all needs to be underneath a radical. And then the question is it a positive or is it a negative? Well, is it positive or negative for our y-coordinate? Our y-coordinate is negative, which means this is one of those cases where it is a negative. So our y is equal to a negative square root of x squared plus 2x plus 4. And I don't remember the scoring guide. Let me come back over here. So solving for y, if I can just get into this form, oh, not that form, this form, but I can leave this as c squared. You can leave that as c squared, and it's still, you'll still get the point. That will give you the point there. So I solve for y right here. So I'll give myself +1. It needs to be a negative also. It also needs to be a negative even if this was a c squared. And then I'm trying to think. So max, note. Yeah, so that's all the points there. Let's see. Did I get all my points? I should theoretically have 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay, so there are 9 points. I got them all. Give yourself the points out of 9 at the top here. And I did remember, let's talk about the domain here for the question number 1. So it's asking state its domain. And this is actually pretty straightforward. So I'm basically, the problem that I have is that this absolute value of x, I don't know if my x's are going to be negative or positive. So essentially I take that inside. If it was 2x, I'd take 2x, or 2x plus 1, I'd take that 2x plus 1, I think. I'm only like 75% sure about this because it's been a while. So take the inside and see it's either going to be less than 0 or x is going to be greater than 0. It's one of these two. And then you come up and say, well, what was our initial condition? Our initial condition had x is equal to -1, so it's clearly the negative version. So I come back here and say x is not positive. Oh, I'm grabbing too much. Stop, computer. Stop. Let go. That one. And there's the domain. So just by saying x has to be less than 0, there's your domain. And I close the self check. If I file open recent 6.2 solution guide, what does it say? that's the wrong one. The solution guide 6.1. 6.1. There we go. If I come down here, it says, oh yeah, and x is less than 0. So that is the domain that you're supposed to be searching for. You just get 1 point if you had the domain correct. So come over here and you can give yourself an additional +1. Cool, that's concludes self-check 6.1 and 6.2. Thank you for watching.